Hello, and thank you for joining us for this Autodesk's latest webinar with Car Design News. My name is Simon Duval-Smith, and I'm an Associate Editor with Car Design News and with AMS here at Ultima Media. As you know, this webinar will focus on new quality standards being set in automotive visualization. Virtual prototyping is one of the most important steps in the development of a new car, allowing the evaluation of a prototype in different aspects before it's even built. Autodesk's new VRED product line can be used throughout the whole design and construction process on a single databasis without the need to redo work. Demonstrating its capabilities today is Alexander Grass, Autodesk Product Line Manager for Automotive Visualization. Alexander was co-founder and CTO of the recently acquired PIVR, adding high-class innovative visualization solutions which strengthen and expand the existing expertise and offerings of Autodesk visualization in the automotive sector. Alexander brings a wealth of experience to the development, testing, and implementation of new features in VRED, with more than 10 years of experience in the fields of virtual reality and high-end visualization. Before we start, I would like to remind all of you in attendance to draft up some questions which Alexander will be delighted to answer in the question and answer session following his presentation. Please ask these questions by typing them into the box in the lower right-hand side of your screen. If you should happen to experience any technical issues during this session, please also type these into the question and answer box, and our team will do their best to sort these out for you. We hope you'll find this webinar stimulating and informative. I'll now hand it over to Alexander so he can begin his presentation. Thank you. Over to you, Alexander.
Hello and welcome everybody to my presentation. Today I would like to speak about, first of all, the new Autodesk visualization, automotive visualization solutions. Autodesk acquired the PIVR company, which were the producers of the VRED products in the end of 2012. And it's now been turned over into a new Autodesk product. And first of all, before I start with the new virtual prototyping field, I would like to explain about the different kind of products we now offer. First of all, virtual prototyping is one, as already said, a very important step during the construction of a car. And as you can see here in a rough overview, the data creation pipeline and as well the visualization pipeline, they're very close together. They need to be connected. This is because the production of that car, the time to the final car needs to be reduced. Okay, so today I would like to speak about the new VRED standard, the new VRED products we have. VRED stands for Virtual Reality Editor. The first one I would like to introduce you is Autodesk VRED. It is meant to be for using for high-quality pre-rendering visualization. It is capable of doing 8-megapixel images and full HD movies. It's the entry-level product for fast pre-visualization on the web. It has the same rendering core like our bigger products I would like to present you later then. The only thing is it's limited in the output resolution. The next thing is Autodesk VRED Design. It is meant to be for the real-time design reviews and presentations. It can be used for data preparation. Optional, it can be used with a display cluster for presenting the output images or the interactive presentations on a power wall. It is capable of producing high-resolution images with unlimited resolution for offline presentations. And optional, you can add additional offline clusters, which means you can improve the rendering speed. This is Autodesk VRED Professional. VRED Professional is a high-end visualization tool. It's a multi-purpose tool throughout the whole process. It can be used for design reviews, design checks. It can be used in the virtual photography field. For example, if you would like to produce so-called prototype shootings, usually it's a very expensive, it's very expensive So you need to ship the prototype. Everything needs to be secured. And then the photographer takes the images only for presenting the new prototype. So this can be done now interactive virtually. And it can be used for marketing imagery and as well with high-end renderings. In the field of virtual prototyping, it can be used for gap analysis and measurements. So during the construction process and the design process, the designers want to see all of the certain aspects. It can be used for surface evaluation on a very, very high level with so-called direct NURBS rendering without the need for having a tessellated object loaded, which means you will always have the perfect shape without tessellation artifacts, the perfect results. It can also be used for evaluation of reflection and refraction behavior. When it comes to real-time ray tracing, it can be used for lighting simulations, for the evaluation of lighting situations for exterior and interior design. And it can be used also for evaluation of moving parts, for example, seat animations, door animations, and so on. It is also be used in certain kind of interactive installations like a power wall, which is a real huge canvas where you have the car and the real size. And it can be used in a cave with tracking capabilities. The Autodesk VRED server, it's a server-based rendering and streaming technology, and it's mainly used for online configurators. It is an automized system which can produce automatically imagery for configurators. And as well as the Autodesk VRED Presenter, it is a custom solution. It can be fully customized, and it's mainly used for projects and point-of-sales installations. Okay, I would like to present you now a rough overview, just the summary of that. So we have here the 5 different product tiers: VRED as the smallest one, VRED Design, VRED Professional, the VRED Server, and VRED Presenter. And in addition to that, VRED Design and VRED Professional, they're offering additional modules like display clustering and offline real-time rendering clusters. Okay, so what is the big benefit about that? As you can see, a VRED database or VRED data file can be used in different kind of application areas, like in the design review with the virtual photography and the virtual prototyping, and as well in the sales configurator. The big advantage about that is you have here one VRED data content can be used throughout the whole process, throughout the whole departments, which means there is no need for redoing the job. I will explain that a little bit later. And here are some images you can see directly rendered out of that software. So this gives you a rough overview about the quality which can be achieved there. Also a very nice aspect in an application area, the VRED technology can be used also for augmented reality. This gives you a rough overview about the capabilities of that software solution. And as well as you can see here, this is a productively used online configurator from Skoda. You can simply go after that webinar. You can go to the website and can play around with that configurator. All of the images here, they are rendered with the VRED server. Okay, so then I would like to start with the application itself, that you can see what it's really capable of. Okay, so what you can see here, this is the actual software. Currently, what we have loaded here is a data set containing around about 28 to 29 million polygons. You can see I will switch simply to the wireframe mode, that you can see that we have here a fully loaded data set coming out from different kind of CAD programs like Alias, CATIA, Inventor, and so on. So let me turn that off. Okay. So first of all, I would like to explain a little bit about what is virtual prototyping. Virtual prototyping means I want to evaluate certain kind of aspects before I even build my product. Whatever, if it's a coffee machine, it's a refrigerator, or if it's a car. So what kind of aspects I would like to evaluate? First of all, how does my object, my product will look like in reality after it is built? So for that, the VRED technology offers a very, very high quality feedback, so-called what you see is what you get feedback. So we're using here, as you can see, a standard studio environment that we can actually see the final results of that image in real time when I move around. And so I can evaluate, for example, different kind of aspects regarding the car paint, for example. So when I go closer and closer, as you can see, this is a metallic car paint. And you can really see also all the different kind of aspects. So it can go really close to the very closest detail, all the little flakes inside, which makes the car paint metallic. Also, when it comes to plastic materials, so I really want to evaluate the behavior also of the materials I would like to assign to make my decision what the real product will look like. Okay, here you can see the graininess of the plastic material. Let me fly into the interior, and then I would like to show you also the interior quality we have. I will open up the door, and let me fly into the interior that I can really evaluate also here on the dashboard the leather structures. So maybe due to the little delay we have, actually the system runs now at 44 frames per second, as you can see. So it's really, really fast feedback. So it's really fluently, like in computer games. So since the software is used also for C-level presentations, there is no time for waiting. So there needs to be really, really fast feedback. Okay, so don't worry. It's only the internet connection which slows the presentation down a little bit. Okay, so what you can see here is the quality of the dashboard of the leather material. When I fly through, let's go to the doors here, and you can see, you can evaluate the material quality, like that fabric we applied here on the inside of that door. So, but this is not all. So not only about the shader quality itself. When it comes to virtual prototyping, of course, when you start evaluating that, you don't want to have it, let's say, especially a car only, you want it to be evaluated with only one single variant. You would like to switch different kind of colors, the environments, or also the shapes itself. So for that, I just prepared that scene that I can simply switch between different kind of environments. That I can see the different behavior of the car. How does my car looks like now here somewhere on the street or somewhere in the woods. So also the reflection behavior changes, and yeah, I get a different imagination about how my actual prototype will look if I'm really building it. Also, we're here in a big garage, as you can see. So different kind of environments really make a difference. So it's not only about having them in a construction program, to seeing them in green, red, or blue colors. You really need to have fast feedback. Of course, there are other rendering technologies, but we have here the currently best achieving results. Okay, and for example here, in a night situation, and as you can see, the car behaves really, really different. Also the shapes here, as you can see now, it goes, this is very, very important when it comes to the environment, that I can really, really see how the shape behaves in that reflection in that environment. And as well, it's not even about the environment, it's also about the car paint itself. What I really can do is just simply hit a single button and just switching between the different kind of variations. Now we have here a unicolor paint material applied. I can switch to a white car or a blue car or an orange car. So this gives you the possibility really to evaluate the behavior of the car in different kind of environments. Also for the interior, when I look into the interior, let me open up the door again. As you can see now here, we have simple seats with fabrics, and I can also switch to black leather material, for example, and then I can start evaluating that. So, and it's not all about the shapes, it's also about the geometry. So during a presentation, during the virtual prototyping, I don't even want to have one single data set. I would like to have, let's say, 3 doors or 4 doors. Let me switch that here. Now I have the 4 doors and the 4 doors version. Or I even can switch between the basic, when it comes to the interior, between the basic or the highline sets. As you can see, it switches instantly. And also, for example, there are also possibilities to turn on and off panoramic roofs. So this is actually one of the first application areas to really evaluate how my virtual prototype will look like in reality. Another aspect we have here is, for example, that we have certain kind of tools during that virtual prototyping process. I would like to look into the car. For that, we have certain kind of tools. We have a clipping tool. You can enable the clipping and can watch inside the car. Let me deactivate the grid that you can see that and decrease the number of the contour width to 2. So what I can really do now is really to clip through the whole scene and to see how is the contour of my car. I can save that contour, can save it, I can reuse it also during the design process. So when I'm not satisfied with the proportions of the car, of a certain kind of surface, I can redo the job again. I also have the possibility to assign different kind of directions. For example, can use the Z-axis and move it up. So I can really evaluate inside that car. Another thing is also during the virtual prototyping process, during the design process, it is what about the gaps? It is a very, very important, let's say, sales argument. So quality, you would like to achieve perceived quality with very, very correct gaps. So for that you have the possibility to analyze actually the gap, how it's modeled, if it's correct or not. So let me show you that also. I turn on the measurement. We have certain measurement tools. And let me create a gap measurement for that. I would like to pick it from here. I would like to evaluate it to that. Now it calculates a little bit, and as you can see now, we have here now the measurement of that gap. When I go closer, I will have here down below the distances in millimeters, the minimum distance and the maximum distance, so I can really evaluate is the model accurately modeled or not. And as you can see, I can move it here. And as you can see, the little bar, the yellow bar indicates where I am currently. So this is really, really important. Okay, so let me turn that off again. Remove all. As you can see, for example, the headlights, they don't look quite good enough, which means they look like chrome and aluminum, like brushed metal and thing, but there's still something missing. This is because we're currently only in OpenGL mode. OpenGL mode means it's only calculated on the graphics card. In addition to that, also to evaluating other kind of aspects like reflection and refraction behavior, because you will get, in reality, when you have a, let's say, the first digital mockup, the first real mockup, you will see when it's covered with a reflective paint, then you will see you have disturbing reflections, for example, and you can also evaluate that. In that case, I just turn on the ray tracing. Ray tracing is a technology for calculating reflections and refractions. And as you can see now, the appearance of the headlight changed. So let me sample that a little bit, the wrong button, that button. And instantly you will receive a very, very sharp result. Okay, so now you can really see the reflections, the reflectors when they are built, so you can evaluate is it okay or not. When I go closer, of course, you can also evaluate refraction behavior, for example, on that indicator. Here's a little glass thing behind with a thickness, and it has a refraction index. And now, as you can see, it starts to refine, and you can really evaluate how the behavior is, that reflection behavior and refraction behavior. Also, when I move to the side of the car, for example, you can see that I really can see from the outside mirror into the interior and have the reflections here. Okay, why that? Imagine you would like to build a car, and let me place my position here inside that car, and I'm starting to evaluating on materials or on shapes and positions of the shapes. So when it comes to the reflections, now I can also evaluate, can I reach out for everything behind me? Can I see everything? Are there disturbing reflections in the outside mirror? Here, for example, okay, this position needs to be defined. And as well, when I turn on different environments, for example, let me switch into more dark environment like that, like a homogeneous environment, like the studio environment. Now we can really see the reflection behavior of the windshields according to the dashboard material. Imagine turning on, or imagine you would like to have a white material applied because it looks really nice and really valuable. But the problem would be then the reflection would be even too hard to see to the outside. So you really can evaluate that in a very, very early stage of developing that kind of car. And you can still move around, which means you still have the full interactivity. So, which means what you see is really what you get. So let me go to the back as well. And you can start evaluating also rear lights, for example, front lights, rear lights. So now it really gives you, that approach gives you now more capabilities to really see what your real product will look like. Okay, so that was the next thing. The other thing, this is the first rendering mode. We have the first ray tracing mode we have, which means in addition to the normal OpenGL rendering, we can apply that reflections and refraction things. But this is not enough. Since we have here, when it comes back again to the gaps, we have so-called static shadows inside. Static shadows means they are pre-calculated. Of course, it is shadowing somehow, but it doesn't matter when I change the environment, for example. The shadow, the gap behavior will remain the same, which is not okay. And our customers were asking for an additional rendering mode where we can interactively also calculate the shadows according to the environment I have. And let me switch that to the next rendering mode we have. Just a second. Okay, I think I moved it down somewhere. Here it is. No, here it is. Okay, this is, I will find it shortly. Okay, then let me switch to another. Let me switch to another thing here. Okay, I take that car. I'm sorry, somehow I don't find the correct rendering, the tab knot, but it doesn't matter. I take that. Okay, so what you see here is not Photoshop. Okay, so what you see here is now looks a little bit grainy. Why does it look a little bit grainy? Now what we do is to really calculating the shadows, the interactive shadows inside. So when I go close and I start to sample that scene, sampling means it starts to calculate shadowing. And as you can see, it starts to calculating samples of a shadow pixel and do that iteratively, and up to a certain quality you will receive that result. And as you can see now, here the shadowing, it directly comes out of the HDR. When I start to switch the HDR, go to, for example, a daylight situation. Okay, now we're in the daylight situation. The shadowing, the shadow behavior changes. Let me go closer. And I'll leave it for now. Okay. Go to a night situation. And it gets darker. Which means now it really is changing the shadow behavior. So shadow and light is everything in design. You need to have that kind of feedback. You really need to evaluate your shapes, your gaps, with having that kind of rendering mode. And as well, we can also turn that in a very, very high realistic way, that we would like to evaluate also the behavior when it comes to turning on rear lights or headlights. So how's the result of my currently modeled design from a headlight or rear light? For that I prepared a little example. It is not a car, it is a chair. It is a chair out of glass. But what you will see here is we have a very, very funny situation here on the ground. I mean, as you can see now, it starts to calculating something. This is a so-called caustic effect. A little light source is placed inside that glass object, and the light rays are distributed in the whole scene, and you will see how the light distribution behaves, which means now you can really see the results of that little light bulb inside this geometry, and the effect on the ground, the effect which will be in the reality. What you see here is the 100% accurate way of light. And what I can do is to take my light and can transform it. And you can instantly see the result. Okay, let me put it a little bit here. And as you can see now the result of the car according to the position of the light is different. Now I can also evaluate light behavior, light distribution behavior, also inside that prototyping process. Another thing for the virtual prototyping process I would like to show you, I'll leave it a little bit, okay? I think you have the imagination about that. As you can see, the light comes from here. The light rays are concentrated here, and you will receive the results. Okay. Another thing I would like to show you is the direct NURBS rendering. So what you actually see here, that car, this is a full NURBS car. What means full NURBS car? It is not a tessellated object loaded inside it. This is all. This contains this object or this car is 100% NURBS. I can show you that in the scene graph. For example, when I select, let's select one patch. As you can see, it's all NURBS. There's no tessellation. So what does that actually mean? Tessellation is a process to converting your shapes you have in mind, the NURBS you construct with alias, for example, or CATIA, and there needs to be somehow tessellated that a graphics card is capable of reading it. Since NURBS ray tracing is brand new, there's a little bit of explanation. The NURBS surfaces, they're mathematical surfaces, so it's very, very complicated to calculate them. With the VRED technology, you are able to really visualize them on a very, very high level basis. To show you that, I will switch into we call it the so-called surface analysis rendering mode. The surface analysis rendering mode allows us to analyze the continuity or the discontinuity of surfaces in that stage on the NURBS basis. So there are no tessellation artifacts. I will show you the difference. So for example, when I would like to evaluate my class A surfaces here, is the modeling correct? Is the continuity correct? Do I have some cracks inside or not? For example, here this could be a problem. As you can see, the so-called isophode rendering, they're not continuous, so it could be a little bit more refinement. We have the possibility to change different kind of rendering modes. For example, I can choose between thin lines or stripes or zebra look. Here you can see it a little bit more better. So when I'm moving the car, I can see really the continuity of surfaces, and so here there could be a little bit more of refinement. So with that process, you can really judge the surfaces in a very early stage to avoid, let's say, anomalies in the final product. Of course, we can switch between different kind of rendering modes. We have the so-called isophode rendering. We can go for highlight lines or even reflection lines. Reflection lines, we can switch between longitudinal and parallel reflection lines. Let me do that with the parallel lines. I will increase the line spacing a little bit so I can really set up a reflection room. So when I now turn the car, and I would like to see how the reflection behavior on the surface is. Let me turn that off. You can see that. Okay. Another thing I would like to show you is that. Let me turn that off. Okay. So what you actually see here, this is a chair using so-called BTF materials. BTF materials are measured materials. So during the design process, when you have textures and materials in mind which you're absolutely sure you will be using, you can be sure that material definition or material finding is always a very, very complicated process beside the actual shape finding or the shape creation. So with BTF materials, you have the possibility to visualize measured materials any kind of material. It could be a reflective material, it could be a fabric material, and as you can see now, the behavior of that material is really realistic. It's accurate. Since it's a measured material, everything is inside storage. So let me show you a very nice material where you can really see what I mean. For example, this is a fabric material, and when I go closer, okay, really close, and I'll leave the image sampling a little bit. It looks really fluffy. It is a measured material, so as you can see, self-shadowing happening inside. It's only a texture. There is no need for adjusting a complicated shader. It's just simply loading that BDF material, and this is it. And to really see what this technology is capable of, let me switch to a very, very nice material we have. Here we go. This is, yeah, you know it from other kind of materials, but I placed it, I assigned that to the chair. But as you can see now, the behavior of that material is very, very nice. So, and imagine applying that kind of materials to a virtual prototype with, so you can be sure, 100% sure, with the BDF materials, this is the material which will be also in reality 100% accurate. It looks like the same. With the lighting, I already showed you with the caustic effects and full global illumination, you can be sure that the lighting situation is the same. So you can push that up to a very, very, very high realistic level to really evaluate the behavior of your car or your model you just created. Okay, and of course, everything what you see here now, this is in that little render window. What you see is what you get. You can render out that images in unlimited resolution. You can use you can use the same data once it's loaded. You can use the same data also in the marketing for image production, for movie production. So I think last but not least, to show you, here we are. Okay, let me switch into that kind of perspective. Let me switch also a very nice environment. And let me turn on my design. Okay, with another environment. There we go. And I would like to render out that image as the last thing for today. Okay, and going for clips. Okay, it doesn't work right now. Here we go. Okay. Maybe going a little bit that direction that you can see it much better. Okay, what you see here, these are camera effects. You can use that for marketing purposes when you want to do rig shots, car in motion. I turned on the headlamps. I have motion blur on the wheels. I have a blurred background. We call that rig shot. Rig shot is usually a very complicated thing if you want to do it in reality. And this is what the photographers are doing right now. And also gives you the emotion about, or the feeling about how does my car look like when it's in movement. Okay, so I think 40 minutes are gone. Yeah, what else can I say? I'm open for questions now.
Thank you very much, Alexander. And thank you for the questions that we've had, which have come into our screen. I think I'd like to start with a question from Andrew Taylor, which is about, he's touching here on CFD and wind tunnel effect. Can VRED, VRED Pro, simulate wind tunnel effect to calculate drag, airflow, coefficient of drag, and so on? Is this appropriate?
No, a FRED is a visualization tool. It can visualize, it cannot simulate. Of course, the lighting simulation, the lighting visualization you saw is some certain way of simulating. But there are tools which can do that very, very much better than for the simulation. But what we could do is if once you have that kind of information, you can store that and you can load it into FRED. It always depends on what kind of data format it is. So main purpose for VRED is visualization. Of course, there's also not wind tunnel simulation, there's also light simulation. If you simulate data and you have data that is simulated already, you can load that in to visualize it.
Yes, yeah. Thank you. I did think that was the case there. Can you tell us, it's a question from Antonio Bertolucci, what are the key differences between Showcase Pro and VRED?
First of all, rendering quality, rendering speed, and complexity. When it comes to complexity, I know Showcase Professional is also able to do a lot of variants and variant sets, but at a certain point it becomes unhandy. So VRED has a better solution for that. So, but the main reason is speed and quality, and it's fully clusterable, which means you can use huge HPC clusters, high-performance clusters for big power wall presentations in 4K or 8K resolution to have that your virtual prototype in real size.
Right. Thank you. Thanks. Renato Olandesi has asked a question of how long did it take to set up this one scene? I think probably not so much, also not only how long, but how much gigabyte or terabyte power is probably required as well. Is it being interesting?
Yeah, I mean there is of course the time. It is a time-consuming process. To set up a data set like that, coming as a let's say from a CATIA file and an alias as a databases, it takes about 5 days to create that kind of scenario. When it comes to the data, you can load as much data as you want to, as long as the main memory is enough. Which means currently I'm using here, let's see, I don't know if you see it, 5 gigabytes of RAM. I can simply duplicate the car, and then I have 2 or 3 or 4. This is also one major advantage. Once you're using ray tracing, you are able, ray tracing on the CPU basis, you are really able to use the full main memory. I will show that. Duplicate. Now it takes a couple of seconds, and as you can see, I instantly copy the file. Here it is. And can turn it to the left-hand side, and then you can see that a copy of that can instantly be used. Okay, here we go. As you can see, 2 cars now, full complexity on one single machine. So it's very, very powerful.
Right, and with ray tracing, then you're achieving not rasterized images, but those with full Bezier curves and vector. I mean, there's no rasterizing, is there?
There's no compared to the graphics card, yes.
Yeah.
But
yeah.
there's also, if you would like to stay on the OpenGL mode and you want to use heavy data like that, now we are with 60 million polygons. I can duplicate that to 120. Let's see how much. 47 million, 57. We also have a so-called CPU rasterizer, which emulates the OpenGL mode, and you can use it in the cluster mode.
Right, and you use that. You could use something like that to move things faster or speed. Or it seems that speed of reproduction of it is not the issue, is it? With the amount of power that you've got.
Yes, it's not the issue, no.
All right, thank you. We have a question here from Alessandro Milite, I hope I say your name right, sir. Which kind of file format can you import? Siemens, PRT, JT, Wire, Autodesk? I know that
we're using, we're using Autodesk Direct Connect, so we can load any kind of construction geometry, which means also JT, Inventor, Pre-Engineer, CATIA version 46, Wire, Alias Wire, a lot of things, so almost everything, NX, and so on.
Right. Yeah, I mean, across all the providers, there's now quite a lot of, there's mainly compatibility, isn't there, from all these providers now?
Yeah, right.
Can the software, it's a question from Alex Nicolai, can the software render NURBS in OpenGL or only in ray tracing mode?
It is only available in ray tracing. In OpenGL it won't work because the approach is different. NURBS surfaces, they need to be ray traced. Of course you can strip it down to a very, very low level format that it looks like, let's say, in any other kind of construction program. But on OpenGL, on an OpenGL basis, it's not possible, since a graphics card can, the only thing a graphics card can do in 3D is to calculate triangles.
Yes, yeah. We're going back to the smaller bit, to the larger bits there, aren't we?
Yes.
You, a question here from Woon Choi Jung. Are the stitches real geometry? I think he's talking about the rendering there of the material. It's a question I'd like to add on to that. Do you take do you get swatches from people making new materials and scan those in?
Yeah, this is a cooperation with X-Rite. So what you actually see here, I hope you see that.
This is the total appearance capture type of technology that X-Rite introduced.
Yes, this is capture technology. So that's a scanned material. There is no geometry. This is only texture. The information of shadowing and lighting, this is stored inside that texture.
Right.
So maybe let me simply switch to another. To that kind, maybe make it more clear here. As you can see now, it really looks, deforming. But this is actually only measured. So all the information you see here, it is measured information according to the lighting situation you have. And this is the unique approach. This is the benefit you have of it. According to the lighting situation you have, the material behaves different.
Yes, thank you. Yeah, that's the thing, that it's so realistic with the TAC, with the total appearance capture. It's quite difficult to believe that it's not calculated sometimes, because particularly the perspective is so perfect as well. We've got lots of questions here. I have another question here from Gareth Davis. Where do you see VRED in the design process when compared to Showcase for the future? I mean, this is what you're backing to a certain extent, isn't it?
Yeah, sure. For the future, I mean, first of all, the capability of rendering direct NURBS. It has a big advantage because there's no need for weight. You can really judge the surface as it is, as it's constructed, and not as it's tessellated. The quality of shaders, the quality of rendering, this is really one of the major advantages you have in the design process. Of course, Showcase is very easy to use, but up to a certain level, when it comes to a certain level, this is very, very complicated to increase quality and really see what you will have in the future. So pushing the quality forward, of course, means you will have more functionalities and more things you can adjust. But you can strip it down only to a very low level. So it's up to the designer what he wants to have. So on the one hand, he wants to have realism, and on the other hand, he wants to have analytic surface analysis.
Right, thank you, Alessandro. We have a couple of questions from Chris Carden of General Motors. He asks, can clipping, can we go up with it, please? Sorry. can a light be keyframed or motion path to move in a scene? That's the light source. Example, say through the glass chair. So can you show a light moving independent of the movement of the main scale?
Yeah, sure. I mean, almost every kind of object is animatable in VRED. So you can also do an animation of the light source when that is the question. You can animate almost everything. You can animate colors. You can animate lights. You can animate motion, material, color changes. You can animate exposure of the lighting environment. So you can dim or can raise the illumination. Hopefully that answers the question right.
Yeah, I think so. Yeah, he also, yes, I think so. Thank you, Alexander. I think he also asks, can clipping be applied selectively to some, i.e. to some, but not all geometry? An example, say, could you clip on the car body but not the interior?
This is something we're working on. It will be that kind of way. Currently not, no. But what we could do, excuse me, what we can do is to define certain kind of clippings placed on a variant set, which means by simply clicking on one variant, the clipping contour, the clipping can happen on different kind of areas. But that kind of feature, yes, this is on our list, and that also needs to be developed then.
So that would give you a palette of that clipping instead of just having to bring in and out different components, for example. Yeah.
Yes.
Chris also asks, he says the BTF looked great, but it looks like it does not have form at the edge of the seat. Is that correct? Like a bump map?
No, there's no bump map. This is only a texture. The information is stored inside that texture. This is the big advantage. So imagine you would like to recreate that kind of shader with a different approach, like the normal CG approach, meaning you have one basic shader and you need to work with a diffuse texture, with a glossy texture, with a specular texture, and with a bump texture. All this kind of information is stored in that single file. So one BTF material is about, let's say, 80 to 100 megabytes. So all information is stored, and also the lighting information is stored according to the lighting information we can switch here. So let me switch to a complicated BTF material, then you can really see what I mean. Is it that the real? No. Let's take, yeah. This is a snake ladder. So first of all, you don't see nothing, and here now it gets really complex. It shimmers in the different kind of let's say spectral colors. So changing a little bit of purple, violet, white, red, a little bit slightly different, and this is really really complicated to reproduce totally virtually. So every kind of information is stored inside in the PDF materials.
All right, thank you. We have a question here from David Almy. Can you show the vehicle moving and responding to variations in gravitational pull and terrain? It's probably going slightly outside the remit of it, but...
I know what he means. The big advantage is you can, we are offering, or let's say VRED offers a basic animation functionality, which means you can simply keyframe. So you have keyframe animations, and this is it. If it starts to get in complex, having damping and gravity and so on, according to the ground behavior, to see how the car behaves on different kind of grounds, you can use, for example, Maya with a plugin, or other external tools which can be, which provides such kind of complex animations with inverse kinematics, with physics applied to that. And you can simply export that as animation as FBX, as a keyframe animation, and can import it in VRED. And afterwards, you can also edit the curves. So let's say basically prepare the animation in Maya, for example, with a very sophisticated animation, with a complex animation, and simply import it in VRED. In VRED itself, of course, you have curves, curve editor, but no, for example, no inverse kinematics or dynamics, physics, and so on.
Yes, yeah. I mean, and Maya, of course, is almost the parent of of the VRED and so on, isn't it?
Yes, it is.
Yeah. I've got quite a few questions here about cost, which you'll be able to see later and pick up with people, Alexander. And I don't think we can probably, it's such a large subject, we probably can't come up with any figures here right here and now, can we? So please be assured, Nitin Vu and the other questioners about cost that Alexander and his team will follow up with you totally.
Yes.
There's a question here from Paul Hetherington. I'm sorry, I don't know Paul, I'm trying to think where he's from. You mentioned a VR integration capability, including for cave systems.
Yes.
Is this feature available in only the VRED Pro version? And what sort of interaction devices are available in that environment? I like tracking systems, hand tracking, measurement tools, ergonomics, etc. So,
currently, the immersive capabilities are only available in the professional version. Powerwall support is also available in the design version. Currently, we have the capability. Let's say we have basic immersive functionalities. So we are using tracking. You can use any kind of open VRPN server device. So you can control ART tracking. You can call. You have the possibility for head tracking, for hand tracking. But when it comes to ergonomics, you can use third-party applications to directly connect.
Right, thank you. Yes, yeah. I have a question here from Shan Guillaume. Does VRED read animation scenes from Maya, i.e. through camera keyframe,
yes,
to achieve the highest CG movies?
Yes, it can.
Right, thank you. And from Lee Ratcliffe here, how is the file management system used to notify the user there are changes in geometry? Showcase currently has this capability, which is a nice feature.
I'm sorry, which feature? I'm sorry, I didn't get it.
How is the file management used to notify the user there are changes in geometry?
Ah, okay, understood.
He says Showcase currently has this capability which he likes. But is this,
this is a good question. There are different approaches. So once you have, let's say, of course, during the design process, the shape changes during that design process, and you will want to see instantly the results. Currently, VRED offers the support for replacing the files, the file structure. So once a new model is ready, you simply can press reload or replace file, and it automatically switches to the new geometry and automatically assigning that shaders. The other opportunity you have is to have a direct database connection. On the database connection like Teamcenter integration. Once you have that, of course, automatic updates will be notified in that database. So there are several options to have always the update, and this is always also a problem, always to have the latest data.
Thank you. And another question from Shan Guillaume. I'm sorry, Shan, I don't know which company you're from, so do forgive me for not recognizing your very distinctive name. RNO, yes, from Renault, yes, I can see that RNO, I should have guessed from RNO. Is it possible to assign VRED materials directly into Maya? And do you plan a built-in version?
Yeah, I understand. Currently, there are no plans for have a direct integration of Maya.
Not in ADSK applications like Maya 3ds?
No, currently not. There are no plans. FRED shaders remain in FRED currently. We have plans to enhance, not to enhance, to add certain parameters that the communication between all Autodesk products will be the same. So no matter where you are, if you're in Maya, if you're an Inventor, if you're in Showcase or even Optical.
Right, thank you. And do you provide a batch renderer?
Yes, we do. We have the integrated system called Sequencer. With a sequencer, you can use, you can make the use of, let's say sequences, as the name it says. You can set up different kind of batches for rendering. You can also use it for interactive presentations when it comes to, for example, here, when it comes to that kind of thing, and I would like to open up the door. As you can see, the little hand I showed before. When I click on it, this is also done by the sequencer. So the sequencer is a multi-purpose tool for batch rendering and as well for interactive presentations.
Right, thank you. Also, we have a question here from Alex Nikolai. Is there a difference in terms of CPU, GPU usage between OpenGL versus ray tracing? And if I can only render NURBS with NURBS with ray tracing, will I have problems in real time, he's asking.
Yes, of course there's a difference between GPU rendering and CPU rendering. Imagine the CPU is a multi-purpose thing, can do a lot of things, can calculate your Excel sheets, can render out images and so on, and the GPU can only do certain things. Limited, but this can do it really fast. But
yeah, he's saying he means with, sorry, forgive me for interrupting you, with the real-time presentations he means.
With NURBS ray tracing, real-time presentations, NURBS ray tracing of course is slower than rendering polygons. But for that, of course, if you would like to keep up the speed, you can add several cluster computers to support the rendering, the real-time rendering. Currently, NURBS rendering is about 35% slower than polygon rendering on a CPU basis. But this is due to the nature of NURBS, since they are mathematical curves.
Right, and they take so much more.
Yes, they take much more calculation time. Yeah.
Yeah. Can we see? I knew this question would come up as we discussed, Alexander. Can we see the effects of accidents on the car through VRED? Asks Nitin Vu. I'm sorry, I don't know which company you're from, Nitin.
Crash model simulation. Yes, you can, as long as the data format you will need to export can be imported. We've done some tests, some format tests with a big OEM, and he rendered out, for example, of his crash test simulation, he rendered out vermal files per frame. So in the end, they had 4,000 vermal frames, and we imported them, and you can press play, and then you can really visualize the effect. This is possible. But a direct connection. I'm sorry?
Yeah, no, sorry, I was going to say, but for test of structures, you would probably use something like PAM-Crash or something like that. Ultimately, wouldn't you? I mean, this would give you a kind of visualization for the sake of observation, but not for pure crash research.
Yes, not for crash research. Yes, currently not. No, only the main intention is for visualization. So. Right. If you would like to visualize your crash data in a very, very high quality like that, you can simply load it in as a vermal file, for example. But to, let's say, do evaluation on that, I would say no. It's just for visualization.
There probably are people out there, Alexander, who are somewhat dismayed at the way their Lamborghini looks after they've crashed it. They would probably like it to look better, and this would help. This could help in that respect. It certainly seems to happen in China a lot. I have a question from Chris Carden again here. Is there a PLM integration solution?
Yes, there is.
Quite a lot, isn't there?
Teamcenter. Currently it's a Teamcenter integration, and of course it is planned for the future to have an Autodesk A360 integration as well, which is the product from Autodesk, A360. But currently we have a Teamcenter integration.
Right. And what about compatibility to other people's PLM? I mean, how widespread will that be? Well, I mean, obviously you want to.
It depends on the PLM solution. Yeah, it depends on the use case. It's not a say yes, we're capable of that and that. It's more like imagine an SAP. It's also, you have a standard product that needs to be customized. It needs to be adjusted according to the needs of the customer. So we've done a lot of things with that, with a Teamcenter integration, with a big supplier, and the whole VR process, design and VR presentation process is based on Teamcenter now. So, but that was an ongoing project. It's not like, okay, install that program and it works. It needs to be adjusted according to the needs. So,
yes,
but
thank you. Yeah.
usually, yeah, this needs to be defined.
Yes, yeah. On those lines, Torsten Steinborn is asking how TCAE integration will cooperate with Siemens tools like TCVIS, TCVIS, and NX. You mentioned NX earlier, but what about the TCAE integration, please?
You mean the Team Center integration? That's TCAE.
TCAE, yeah, the computer-aided engineering integration, yeah.
This is a very specific question. It always depends on the needs of the customer. I mean, we have that integration. Unfortunately, I cannot tell the name of the customer currently, but it runs very well. Also, when it comes to NX, everything will be stored inside of that Team Center, inside Team Center, and it can be direct. There's a direct connection, a direct database connection. So shaders are stored inside the database. All the geometries there as JT, as NX, and also at the VRED native file format. So once the designer updates his model, there's a single button pressed to TCA, and then it will be automatically replaced. The shaders are automatically assigned and can be used for, let's say, marketing material or a VR presentation on a Powerwall.
Right, right. Thank you. I have another question from Shan Guillaume here. Saying a lot of people have asked about UV mapping. Do you provide tools for UV mapping, or do we have to make it on polygons in another application?
Externally. Currently, we are providing triplanar projection with edge blending technology, which is, let's say, 90 to 95% in the case totally enough. But when it comes to, for example, here you have the stitches, now they are geometry. If you would like to unwrap them, currently a VRED solution is not capable of doing that. This needs to be done externally. But for example, there's that leather structure here you see. This is no unwrapping. This is directly triplanar projected, and the edges are blend together, that you have a seamless projection.
Thank you. I've got a question here from Jose Alberto Torres Giarote. Hope I said your name correctly, sir. Which versions have VRED web interface to interact with the model?
It is version professional. The professional version has that HTML web interface.
Right. Thank you. And which version of VRED will replace Showcase Pro? Asks Woon Choi Jung.
That will be determined later. Then I won't talk about that. It's not 100% sure now, but there will be this information soon.
Right. Thank you. And Gareth Davis asks, and Gareth have a message from Woon Choi Jung, who says hello. We don't normally pass messages on here, but Gareth, I think you're from Land Rover, Gareth, as I'm not quite sure as I remember. Perhaps you could send us a message. He asks, is it possible to create your own custom BTF materials within VRED?
No, you need a special device for that. It's most of the times, I think X-Ray provides that kind of device. So once you have that device, you can scan in the data and you can directly load it, but you cannot create a BTF material inside VRED. The only thing you can do is you can work with the VRED provided shaders. Yes,
yeah, and I think that is something from X-Ray, yeah, from the new total appearance capture, yeah. I have a question from Anthony Burgess, again about UVs. Are the UVs on the seat, I think you might have answered this actually, are the UVs on the seat sorted in Maya before being brought into VRED?
Yes. But on that seat there are no UVs. This is triplanar projected, but the normal approach would be to have first unwrapped the geometry in Maya, and then you can import it in VRED.
All right, thank you. Guillaume Vasseur asks, could you use VRED to make short teasers and movies And could you easily integrate it into an animation workflow? I think thinking here for marketing purposes and so on.
Yes, you can do that. You can do that. I think we also have some examples, I think on YouTube or on the former PIVR website. I think there are some movies created directly out of FRED.
Right, thank you. And I have another question here from Antonio Bertolucci. Do you think VRED may be usefully applied to other markets, like interior design, not of cars, and consumer products? And what about virtual visualization of lighting in reference to photometry values? So we're touching on UV here, but...
Yeah, I mean, this is also a major part of virtual prototyping, photometric values. The latest version, VRED 2014, which was released a couple of weeks ago, is capable of doing spectral rendering, which means on a wavelength basis, you can set up your rendering on a spectral basis, which means the colors you will receive, they are correct. And this is also something when it comes to light evaluation, light temperature evaluation, for example. This is what we can do right now. And I missed the first part of the question. I'm sorry.
First part of the question. Sorry, it's gone. You will get that question. I'm sorry, it's gone off our screen. Just to move on to, you will get that question, Alexander.
Okay.
A question from Katsuhiro Muruhana. Do you have a turntable function like Showcase? And what kind of VR function do you have? That's probably explained there, but we've kind of seen the turntable function. You can fully rotate, can't you, as in Showcase?
Yes, you can do that. You have a turntable function, so-called turntable angle in the camera module. So when you want to animate, you simply can animate that turntable angle and can define the rotation of it, 180 degrees, 360 degrees. And then, of course, you can render that out, or you can play that interactively. VR tools, what does he exactly mean with VR tools? Like the clipping, the measurement, or like the VR interactivity on a cave implementation? We can connect space.
Sorry, he says, what kind of VR function do you have? I think that is in most of your presentation, but maybe Kazuhiro, if you are still there, if you want to expand on that. And I'll move on to another question. Does it support animated NURBS or polygon deformation from third software such as Maya or Max?
Yes, it does. It does so-called vertex cache animations. Deformed vertex cache animations on a polygon basis. Yes, like opening a roof from a convertible. If you would like to visualize that, yes, it is supported, but only on polygons, not on NURBS.
Right, right. So that detail would be good enough for most things, but perhaps not for putting into print or something like that. It would, on a polygon basis, it would be quite fine, would it?
It is quite fine, yes, yes. You can use a very, very fine tessellation.
Yeah, right. Yeah, so Gareth Davis has just told us he's the studio director of Technicon Design in France. Thank you for that, Gareth. I have another question from Guillaume. Actually, I've got a question here from Sebastian Chevreal. He asked, will VRED be part of the Autodesk product design suite as such?
This is not decided yet, but we will update you.
Okay, thank you. Thank you. And Guillaume Vasseur asked again, is it possible to create an auto-executable application from a scene that you can deliver to a client?
No, currently not. For that, you need at least the presenter application to load in the data.
And that's
so you do not need the full program. It needs to be prepared with one of the three programs, like VRED Design or VRED Professional. But once you have that created file format, you can save it as a single file. And the potential customer or client, he needs a viewer, the presenter system, to have that visual feedback and all the functionalities.
So, and that's a generic type of presenter program. I mean, from more than one provider.
It is a separate product, yes. So you definitely need the presenter to display VRED files.
Right. A question from Lionel Gruff. Is there a limitation in the number of artificial light sources we can create in a scene?
No. Depends. In OpenGL, yes, but this is due to the limitation of the graphics card. There can be 8 light sources per node. This is the maximum of OpenGL, but in ray tracing, you can set up as many light sources as you want.
Yes, right. Alessandro Milite asks, are there augmented reality functionalities? Is that clear? Yeah.
Yes, clear. Yes, but only for a certain kind of application area, not on a global basis. But this is something we also talk about, and there will be also updates soon.
Thank you. Another question from Sean Guillaume from Renault. What about the material shading language? Is it a VRED standard, and is it possible to create materials out of the box?
It is possible to create materials out of the box, but they are not, let's say, externally controllable. They are internally created. So VRED offers shader groups like plastic materials, metal materials, and paint materials, and but they're not programmable. You can combine them with the multi-material, but you cannot program them like in Maya, for example, with C++.
Thank you. Another question from Chris Carden, one of our most prolific questioners here. He asks about selective clipping, animation of lights, moving lights across an object or scene, and is there no displacement or bump at the edges with BTF?
There is on the edge, okay, starting with the BTF, no. Since it is only the scanned data, this will be improvement. We will have discussions with X-Ride about that we also can achieve displacement or bump mapping in the edges. But currently, it is only what you see as only the effect of the lighting of the texture, of the scan texture. Then the other question, yes, it is movable. It is possible to animate a light source moving across a surface, for example. Very easy, keyframe animation. And then I didn't get the other one. Sorry, I forgot. There was one question missing. The first, I think.
Yeah, just a moment. I think some of these were probably answered. He asked about selective clipping, animation of light, which we've covered.
Animation of light is possible, but selective clipping not, currently not.
Right, right. Thank you. Again, lots of questions about pricing from people, but you will get to those personally. Please, everybody be assured. I know that Alexander will follow up. Is there a Mac OS version of this, or is it all on a Windows?
Currently, it's on a Windows, but a Mac version is planned.
Well, we've got a lot of questions which are all going to be forwarded to Alexander, and Alexander will. Some of them are very specialised, and I think it may not apply to everybody's interest. So I shall take the liberty of referring those on to Alexander, and I know that he and his team will answer you all personally. I'd like to thank you very much for joining us today, and thank you, Alexander, for a very informative webinar. The webinar will be uploaded into our archives, and it will be accessible in the future for you and all of your colleagues who might not have been able to attend the live presentation. You can access this and any previous webinar under the Process tab on the Car Design News homepage. So I want to say thank you very much for joining us today. We hope you'll join us again in the future for our next webinar. I want to thank Alexander very much indeed. This is a very complex subject, and we may have only just touched on some of the main features, but I know that Alexander is keen to follow up with all of you who've attended. So I want to thank you all very much indeed for attending. Thank you very much, Alexander.
Thank you.
Okay, and goodbye. Thank you.
Goodbye. Thank
Bye-bye.
you. Bye.